Rather than use PowerPoint, let's explore some Yang models using our trusty PyYang tool, this time focusing on NXOS interfaces using the OpenConfig models. Most Yang models are accessible via GitHub by performing a clone operation, and I'm showing the repository for the OpenConfig or OC models. These are vendor-agnostic models designed to represent highly standardized features such as interfaces, VLANs, and routing protocols. Let's go to the shell so we can clone this repository using the link shown. I'll use the git clone command followed by the repository's link. I'm also going to call this directory YangOC instead of public because the former is more descriptive. This repo has many files. Here are the directories where we will focus our efforts. In the next clip, we are going to collect the switchboard details from a Cisco Nexus switch using netconf. For that, we'll start with the OpenConfig interfaces model. Let's use PyYang to transform it into tree format using a bash script named maketrees.sh. We use our standard PyYang command with the tree format. Because these production-grade models are hierarchical and import other models, we must specify a search path so PyYang can resolve dependencies. I'm also redirecting the output to a file called ocintf.txt for easy access into the data reference directory. I'm repeating a similar process for a few other models, which I'll explain shortly. We'll quickly run this script. Next, let's analyze the interfaces model first. At the top, we see the module named OpenConfig Interfaces followed by a container named Interfaces and a list named Interface. This should look familiar as it's quite similar to the homemade Yang model from the previous module. Because name is in square brackets, it's the key attribute for each list element. Notice the rwconfig line, which contains one set of attributes, and the rostate line that contains a larger set of attributes. RW means read-write, and RO means read-only, and naturally RO tends to be a superset of RW. We can use this model to collect information about the interface, such as packet counters and port status, which aren't things you can configure. Let's take a quick look at the Ethernet-specific interface model. This file doesn't add anything terribly important, but it's a required in-between file. At the top, notice that this structure augments the more generic interfaces model we just reviewed. Now, let's look at the VLAN model, which describes VLAN-specific configuration. I'll jump down to the section that covers VLAN assignments. Even though the Ethernet interface model didn't provide any useful attributes, it is augmented by the VLAN model. This is where we can see important attributes such as the interface operating mode, access VLAN, and native VLAN. The interface mode is an enumeration and must be either access or trunk according to the screenshot. This is a custom data type and helps constrain the data values. Hopefully this next screenshot looks familiar, which constrains the VLAN ID to a number between 1 and 4094. As we learned in the previous clips, netconf uses XML payloads exclusively, so how can we logically build an XML payload from this tree? We'll cover that in the next few clips.